participants. I thank the organizers for giving me opportunity to share whatever I have come across a little bit about fuzzy set theory and fuzzy topology spaces. So I will share that one. At any time you can disturb me, you can ask if you have any doubts actually, or if you want to clarify me, you can have suggestions also. I expect suggestions so that I can improve, bring in changes in my thought also. So this is the title of the topic. The title of the topic is very large actually, but I will consider only some aspects, and those aspects I have come across while working on fuzzy set theory, particularly fuzzy sequence. My area of research actually I started in sequence basis. That is under summability theory. I applied functionalistic technology like Prof does. So he has used also the work on summability theory. Now, this particular figure is well known to us, that is George Cantor. So he was mainly responsible, and he has taken the credit also to have a systematic study and give a definition of fuzzy set theory. That is a well-defined collection of distinct objects. Of course, people say that it is not properly defined also, but still it is very close to the definition of set theory. And along with him, Richard Dedekind also, he has contributed a lot in bringing changes in the concepts of set theory, and both of them work together. And as you know that sometimes we prove it but we cannot believe it. So Cantor, he wrote to Dedekind that he has established a relation between Rn and R, but he cannot believe it. Now also we are reading in grade level that R is in one-to-one correspondence with set of unit interval, that is 0-1 interval. So that we cannot believe also, because one set is unbounded, the another set is very finite, very small of unit length. And this is about the definition. The main aspect of the logic that was developed by Cantor, and later on it was subsequently investigated by Dedekind and others also, that the logic is two-value logic. Two-value logic in the sense we have either true or false. So in this true or false also represented by 0 and 1 also, when you consider 0 and 1. So 0 is false and true is 1. And the theoretical mathematics, that is pure mathematics generally, we consider it to be the axiomatic set theory. Axiomatic science also you can say. We define some axioms, just like sometimes back Professor Hazrik asked that why you have 18 axioms, 18 conditions actually. If those conditions satisfy, actually you can say it's a group or ring or whatever it may be. These are axiomatic study. So there are a lot of changes, lot of requirements actually. Necessity is the mother of invention. So the concept of fuzzy set theory was introduced by L.H.J.D. and L.H.J.D. he introduced in 1965, but he had to undergo a lot of works actually before coming to that the notion of introduction of a fuzzy set theory. And about this one actually in one lecture, Professor Balas actually of Romania, she delivered a very essential lecture actually. We have record of that lecture also, that how he came to such a the definition of fuzzy set theory, how he could introduce it, and what are the difficulties he followed. And before that he published many articles where he hinted about fuzzy set theory, but he could not give the concrete definition. Now actually he introduced the definition here. So in our daily life, what happens in case of Cantor set theory, that logic that we develop, either true or false. So in between there are sentences, those are neither true nor are false, sentences. So statements only you can give the value true or false, but sentences you cannot give the values true or false. So there might be in between percentage of truthness, etc. is there. So how much it is true. Based on that actually, J.D. actually in 1965 introduced the concept of fuzzy set theory, associating each member of the set, an universal set, is considered universal set, because we cannot run away from the set that is given by Cantor. Whatever we define, we will define based on set only. So that set again you have to go, and based on that set we have to define the membership values. So he is given, since the truth value is 1 and false value is 0. So he raised the percentage actually. It varies also person to person, situation to situations. see, just like the students, they get percentage also, percentage out of 100, then you can reduce it to scale of 0 to 10, then you can further reduce the scale of 0 to 1 also. So this way you can think of having the concept of fuzzy set from the whole concept. A fuzzy set is a non-empty set E together with the grade of membership, and the grade of membership, as I have said you already, that it lies between 0 and 1. Now the question is, what exactly is a fuzzy set? Whether you have come across fuzzy operations earlier or not. So fuzzy set theory, we have done actually, we consider a universal set, universal set. The cases we restrict to ranging between 0 and 1, and further in case of general functions, the functions values actually, when you add the functions, at that time we add the functional values. But in case of fuzzy set theory, when you consider the fuzzy real numbers also, in a particular case actually, fuzzy real numbers defined over the fuzzy set over considering the universal set of real numbers. So we consider the alpha chords. So in this case, the fuzzy real numbers we consider as convex, upper semi-continuous. Upper semi-continuous continues from the chord is continuous from the right in the left, and on the left it's continuous from the left. The reason is that when we take the alpha chords will be in the form of closed intervals. I will come to later on interval sets. So interval sets, and we consider also normal. Normal means it should represent 0 to 1. That means in the particular case when we consider, the intervals will not be empty interval. So for that we consider the upper semi-continuity, and also the normal we consider. So we can say this is a generalization of the original Cripps set theory, that is Cantor's set theory. And for this we can have the one can read, actually the beginners can read the book of G. Bordeju and M. Bordeju. They are husband and wife. They have written the book published by World Scientific. If you read this book, actually it is a very good book. I understand there are some typographical errors, and the typographical errors are necessary so that the person who is reading it will be very much careful about it and will be able to understand the concept himself. So he will not forget it. So this book has a lot of conceptual and typographical errors also, so you can correct it. But it is a very simple book. They have started with the interval numbers, then discrete fuzzy numbers, then fuzzy numbers. So discrete fuzzy numbers, they are called from two-valued logic. Whatever Z has introduced, it is a many-valued logic. And for when you consider fuzzy real numbers, we consider the continuous valued fuzzy real numbers, that is ranging between 0 and 1. This interval valued logic, yes. I think I am audible. So interval, generally we consider the closed intervals, but we